Welcome to Thermo-Fluids Lab, MECH MECH 3313, and I will be your instructor, MD Khan. Before we get into the course, let me give you a little bit of introduction about myself. As I told you, my name is MD Khan. I'm a PhD candidate over here in Mechanical Engineering Department. You have my email number, so you can reach out to me with any questions or any queries you might have over the semester. I have been teaching this course for about 3 semesters now. So I am, my dissertation title, it kind of aligns with the course. My expertise include heat transfer, CFD, solid mechanics, and solid modeling, meaning CAD, FEA, etc. So, since my expertise have heat transfer, thermodynamics, and CFD in it, so the department decided that I'm a good fit for this course to teach. Just in case you ever get curious, my dissertation title is Combustion Analysis and Experimental Investigation of a Coaxial Dual Fuel Coal Natural Gas Oxycombustor. I know it's a mouthful. So what I basically do, I burn fossil fuel, and I try to bring out more effective ways of combustion, and I try to do it in a greener ways, meaning the exhaust gas will be less pollutant. So it involves a lot of mathematics. It involves a lot of analysis, combustion. Heat transfer analysis, a lot of thermodynamic, FEA, using a lot of different numerical tools. So not only for this class, if you have any question about anything in thermodynamics, heat transfer, or FEA in general, you can always come and ask me. All right. By the way, I'm assuming that you guys have no trouble hearing or seeing my screen. Is that correct? Okay. So, okay. Well, thanks, Carlos, for confirming. So in this lab, the name says it all. It says it's Thermo-Fluids Lab. So we will study thermodynamics, and then we will study a little bit of fluid dynamics as well. When it comes to thermodynamics, we will study heat transfer, different mode of heat transfer. We will study different convection. It's another mode of heat transfer, but unlike conduction, where you use only metal, convection happens when you have only fluid, or it can be done between fluid and metal surface interaction as well. Okay, so in the convection, what we do, we're going to study the energy balance. We're going to study different mode of convection. So when there is a natural flow, for example, when you're sitting in your room, there is no fan or no turbine around you. Whatever fluid around you, it's static. It doesn't change its velocity. It doesn't change its properties with time. So that's what we call a natural convection. But when there's a flow involved, meaning when you have a fan or you have a wind turbine or anything which pushes the fluid towards a direction, this is when you're going to have forced convection. So we will study both forms, and in the process we will study the Newton's law of cooling. Okay, it sounds kind of hard, but it's pretty complicated. It's pretty simple. Once you will see, you know it's not that tough to calculate. So after conduction and convection, we'll move on to the radiation part. But the study of radiation is going to be a little bit of different. We're going to study how we can generate power by absorbing the heat that's being radiated from the sun. So we'll study solar collector. There are different types of solar collectors. For our course, we'll study flat panel and parabolic panel. Okay. Um, I won't get too much detail in here since it's an introduction class. I don't want to overwhelm you guys with a lot of information. But I will pause over here, give you guys a minute to ask me any questions you might have so far up to the 7th slide. Well, if you don't have any questions, then I'm going to continue. All right. Okay, Adrian is asking regarding to the PowerPoint, will we have access to it? Yes, you'll have access to it. I will upload all the materials regarding the courses on Blackboard. So once we're done studying different modes of heat transfer, we'll move into the study of thermodynamic cycles. So we'll study Rankine cycle and we'll study Brayton cycle. So there are some fundamental differences between these two cycles, Rankine and Brayton. The first one is that Rankine is a closed cycle and Brayton is an open cycle. And what do they do? As I mentioned before, that these cycles, they study or they tell us how to move energy from one point to another. Meaning you will have fluid in your cycle, in your either if I want to give you an example, let's say in your fridge, you have some freezing liquid. That liquid absorbs heat, it changes its phase, it becomes gas. From there, it moves on to somewhat hotter zone with high temperature. Over there, it changes its phase again, and then it releases all its heat. It comes back to its initial state. So these cycle, there are different ways, there are different processes of the cycles, and we're going to study Rankine and Brayton of those processes in this class. So Rankine cycle is used to study steam engines or steam cycles. So your primary fluid in here will be water. So you put heat into water. Water is gonna absorb. You're gonna press it. You're gonna change its phase, and then afterwards, eventually after the whole cycle, it's gonna come back to its initial phase. You will burn fuel to add heat to the water, and we're gonna study different sorts of fuel as well in this in the Rankine cycle study. And then the Brayton cycle, it's used in gas turbines. So it's an open cycle. Unlike Rankine cycle, the same liquid, the same water doesn't come back to its initial phase. What happens is that you take fluid in one side, you're gonna press it, it's gonna burn, you're gonna put heat into it, and then you're just gonna open it, you're just gonna let it go into the open atmosphere. And the fluid is air for this specific case. Now it's only possible because the atmosphere, the gas it's leaving the hot air at, it has the same thermodynamic state as the intake, meaning your point 1 and point 4 have pretty much the same thermodynamic state. That's why you don't necessarily have to bring the fluid to its initial phase by yourself. The environment, atmosphere pretty much does it for you. Okay. Okay. Pierre has a question asking, so will the labs be like analysis? No. Unfortunately, this semester we cannot have these labs in person, because of the COVID thing. However, what I'm gonna do, I'm gonna demonstrate those experiments, and I'm gonna tape them. and I'm gonna make them as explicit as possible so that you can have pretty much the similar understanding if you were to do it in person. So uh, to answer your question, yes, in most of the labs, you have to do some sort of analysis. As a matter of fact, that's the heart of the experiment. You analyze the facts, you get the data, you find out the physics, and you explain it. But you're gonna have to do it virtually. That's the sad part. Okay. So yeah, that's we're gonna we studied ranking cycle, we studied Braden cycle. So after that, we will move on to the viscosity thing, where we will use viscosity of different oils, different liquids. So what we're gonna use this rotational viscometer. Yeah. So it has a rotary disc in it. It's gonna rotate inside a fluid, inside a liquid, and we're gonna heat it up. We're gonna see how the rotation changes with temperature. So you can have a better understanding the changes of viscosity for different oils um, with temperature. Also, I'm not gonna tell you what oil you're gonna use. So based on the values, you also have to find what oil you're using in your experiment. Any questions so far? Okay. All right. After that, the final experiment, which is gonna be a study of turbo machinery. For you, it's a centrifugal pump. Um, it kind of so we studied how you can move energy from point A to point B. Now you're going to study how you can move uh, fluid from point A to point B using different kind of energy. The one over here, the one what centrifugal pump uses, it uses mechanical energy or rotary energy. It has an impeller in it. It rotates and it takes fluid from point A to point B using this rotary force, rotary energy, this mechanical energy. And when you're going to analyze this experiment, you will also study Bernoulli's principle. Uh, I'm pretty sure since it's a 3000 level course, you guys already are familiar with Bernoulli's principle. But if not, let me know. I can I can take a longer class on that. After that, the wind tunnel. Um, over here, you study how fluid exerts force on different geometry. So you have this big wind tunnel set up, and you have your specimen. It can be of variety of geometries. It can be circular, it can be just a disc, or maybe a cylinder. You put it in here. You let air pass through this tunnel. You put a velocity in it, and then you study how what kind of force you're seeing in here. You have a pitot static probe. Using that, you can measure forces at different points along different axes. So, it's going to be interesting. You're going to change the velocity of the wind turbine, wind tunnel, uh, and you'll study how the forces change with the change of velocity. After that, another way of harnessing energy, which is the wind turbine. Um, as you know, that renewable energy is getting more and more popular. Different modes of collecting renewable energies are also getting popular. So this wind turbine is one of them, and the name pretty much says it all. It's you have a turbine. The turbine is moved or rotated with wind. So wind puts its kinetic energy into the turbine, and the turbine converts it into electrical energy. So in your experiment, what are you gonna do? You're gonna study the change in resistance, uh, meaning you're gonna change the load on the electrical side, and you're gonna see how it affects the electricity or the energy generation. Okay, so pretty much it. That's all the experiments that you have to do. 10 experiments. Some of them involved with pure thermodynamics, more of heat transfer analysis. Some of them about harnessing renewable energies from our environment. Uh, some of them have, studies of turbo machineries, and then you also have studies on viscosity. Any question? Okay. Pierre has another question. He's asking, will you be helping us by telling us what to compute and put on the report? Yes, that's why I'm here. uh, I'm going to explain all this stuff in a bit. Let me know if you can see my screen now. Okay. So I'm showing you guys the lab structure, and I'm pretty sure you all have a lot of question about the code structure, how it's gonna run. Uh, after going through this PDF, if you still have any question, let me know. So right now in here, I have two sections, and I understand that one of the sections they signed up for Tuesday. I wanted to move it on Friday, but I think it's gonna clash with a lot of students' schedule. So I will have to like keep the Tuesday schedule as it is. But I'm gonna ask the Friday people if you can like do these classes on Tuesday from 4:30 to 7:20. It's a proposal on the table. Um, Let me know if any of you have any issue with it. Email me, and if not, then we're gonna continue this class from Tuesday from now on. Okay. All right. So, well, here's my email. If you have any question, you can shoot me email over here. Okay. I think you guys can. How about now, David? Can you see my screen now? Okay. Okay. All right. Um, yeah, the schedule is not fixed yet. Like we will talk about it. Just let me know if you have any issue with Tuesday from 4:30 p.m. to 7:20 p.m. Okay. But you know what the chat thing is? I mean, I have to like go between my PDF and the chat. So if you have any question, you can just like ask me, interrupt me in my lecture. That's okay. I mean, of course, if you have access to your microphone. Well, what's the course objective? So the course objective is pretty much, from my point of view, is to make sure that you learn, is to make sure that you understand what knowledge comes to the experiment. And to do that, I will do whatever needs to be done. For example, I will keep throwing you guys different extra credit assignments so that you can improve your grade over the semester, and you can also learn from them as well. And uh, or let me just explain the course structure a little bit. So the way it's gonna go, it's a cycle. It's each week cycle class, meaning you have to submit one report every week. So today is the first class, so no report next week. But after the first lecture, you're gonna have to submit the report on the next week, the first report on the next week, and the second report on the week after. And the week when you have the second report due, we'll have our second lecture. So you'll see me virtually you'll see me virtually every other week. Either you see me in person in meetings as Zoom or Blackboard meeting, or I can upload pre-recorded videos explaining this stuff. But either way, you will have access to me. So even if you are stuck somewhere, it's okay. You can ask me. Um, I'm planning to take two quizzes, big quizzes, the midterm quiz and the final exam. And I will try to give you guys a couple of surprise tests every now and then. But those surprise quizzes, they're going to be MCQ questions. So it shouldn't take you more than 15, 20 minutes. It's going to be very simple. If you just go through those slides, you should be able to answer them. So beside those class quizzes, we will have two big quizzes, a midterm quiz and a final quiz. Now, I'm saying those big because I'm going to allow you guys about 2 hours or so to answer those. But the format is, it has MCQ and it's going to have some math problems. Those math problems are going to be tied to your experiments. So if you know your experiments well, if you have done the calculations in your experiments, then you should be able to answer those questions. No extra study is required. So midterm quiz will have somewhere around 8 weeks, meaning where you will have your spring break before or after that, and final quiz is towards the end of the semester. Okay, and I will cover 2 experiments per lecture. Any question? All right. How you're gonna get graded? Well, as I told you, that the course objective for me is to make sure that you learn. And how can I make sure? You have to show it to me, meaning you have to prove in your report, in your exams, that hey, I've learned this stuff. So for a lab course, there is no better way to investigate the learning process other than the report, the lab report. So the heart of your course is the lab report. It's 70%. I'm gonna give you guys a few sample lab reports as well, so you can just see what structure I'm looking for, what you should put in your report at. Once you are accustomed to the course structure, once you totally know what it needs, I'm gonna stop giving you those sample lab reports. However, I'm gonna go through. I'm gonna upload a lot of videos. I'm gonna upload a lot of experiment demonstration. What you have to do from your end, you have to be extra vigilant. You have to always keep a lookout in Blackboard to see if anything new is uploaded, if any new announcement is being posted. Sometimes what happens is that the announcement goes in your spam folder. So just make sure that that doesn't happen, and you're always aware of what's going on. Now these reports are going to be a group report, and I'm going to pair you guys 2-person in a group. I would ask you guys to make your groups, and before next class, I'm going to make a discussion board on Blackboard. So over there, you just write down whatever your group number is, and your group member's name and their email ID. And now again, I understand that it's not an in-person class, so maybe some of you will have a hard time communicating with somebody else, like pairing a group, finding somebody else. So I'll make another discussion board over there, so you guys can find pairs amongst each other. And even after that, even somehow you miss that, you can email me towards the end of the week, and I'll pair you up with someone else. Any questions? All right. So the reports are 70%, and then the class performance are 10%. Midterm quiz is 10%, and the final quiz is 10%. I think I have a question. Pierre is asking, do we get a new partner every week, or is it consistent? No, it's consistent. Yeah. Okay. So that about it for the introduction. Oh, and for the class attendance, I'm gonna make it asynchronous, so you don't necessarily have to be present at all the classes. However, I strongly recommend you to be in the class because interactive learning is always better. And you know, when you ask any question in the class, you can not only learn from me but also from your peers. And I encourage you. I don't discourage you guys to you know getting ideas from each other from different groups. However, do not copy paste each other's work, and you know do not copy paste anything from online. If it indeed happens, then I'm gonna have to degrade your grading, and you know I have to punish you that I really do not want to do. All right. And yeah, if you have any special need of any special recommendation, you can always contact me. Yeah, that's about it. We're planning to finish this course in 13 weeks, but depending on how you know how you guys are moving forward, based on that, we're gonna add more weeks to it. You guys have any questions? Okay, I'll pause the video over here right now. And oh, by the way, I will upload all these videos on Blackboard or on YouTube. So even if you miss the class, you can always go back to it and learn from it. Okay. Okay, I got a couple of questions. Okay. So first, Carlos, you're asking when will the discussion board be posted? It's pretty soon, today or tomorrow. Pierre, you're asking, so the lab will still be on Fridays. Okay, I think that's a big question for you guys. No, I'm proposing you guys that if you can take the class, the, all the students who are supposed to do the class this time, Friday 4:30 to 7:20, if you can attend the classes on Tuesday from 4:30 to 7:30, that would be great. Um, because I was thinking about moving the Tuesday class to Friday, but it clashes with a lot of students' schedule, so it can be done. Yeah, so just let me know if you can't do on Tuesdays. All right. If we can email you. Yes. I mean, I think Pierre, you already you know expressed your concern, but yes, do email me. All right. If you guys don't have any question, I'll pause the video over here. I'll stop the recording, and I'll wait for a bit for you to ask me any questions or anything you need to know.